Welcome guys, welcome to this Whizlabs OCPJP 6 training demo. Let me begin by just giving a brief introduction of mine and a little bit about OCPJP 6 exam, and after that we will go into the topic or the technical topic that we want to discuss today. Today's topic would be actually a sub part of collections framework. Basically the use of comparator versus comparable interface. It's quite confusing, I have seen, to a lot of people when to use which one and what is the difference between two and where exactly they are actually used. So we will clarify that whole stuff today. But before that, as I said, let me just give a brief introduction of mine and OCPJP, then we will go to that. Okay, so a little bit about my credentials. So I did my SCJP certification in December 2009. Then I did my SCWCD certification as well, which is the Web Component Development Certification. I did it last year, and I have training experience of well over 3 years with Whizlabs. Now, well, it's almost touching 4 years now. Little bit about OCPJP 6 exam. So OCPJP 6 exam is total duration of the exam is 150 minutes. The number of questions that you need to solve in it is 60, and passing score is 61%. Now, there is this book called SCJP 6 Study Guide by Kathy Serra and Bert Bates. This is an excellent book for preparation of this exam, and this is the book that we recommend to each and every SCJP aspirant. And in fact, this is the book also that we follow in our 4 days of training. Okay, and you can see the 7 sections that you can see on this screen here are basically the division of SCJP 6 syllabus, and these divisions have been done on basis of this book, Kathy Serra and Bert Bates, so that the training participants can follow it easily, right? So you can see these 7 sections, and on this next slide here, you can see which section is covered on which day. So based on the logical flow of syllabus, it's mostly governed by the order of topics in the books. We cover, you can see all the topics from day 1 to day 4. Alright, so that was the very brief introduction part. Before I go to the technical topic of collection frameworks, anybody is having any questions? No questions? Okay, I don't see any questions in the questions panel here, nor do I see any hands raised. Let me just check and confirm if there are any hands raised or not. Okay, so there are no hands raised and no questions, so I will proceed ahead. Okay, so I will start with the technical discussion now. Okay, so for that, let me just create a sample class which will form our basis of discussion today. Alright, so what I'm doing is I'm creating a class called student, very simple class, as you can see. I'm just going to add a few things. So you can see instance variables in this class, name and roll number, and then I have added a constructor in this class as well, which is just used to initialize this name and roll number field. Now let's say we have following code. So you can see these two student objects that I have created. Now my question is, what is going to be the output if I say this? If I say st1 double equal to st2, what is going to be the output? I'll just wait for people to just think about it and write down their answers here. So I will encourage everyone to actually participate here and type in whatever you think is correct. Okay, I can see few trues and I can see few false as well. So guys, the correct answer here is actually false. Okay, the reason is what is st1 and st2? st1 and st2 are basically object references. Okay, and the value of an object reference is the memory address where the actual object is stored, right? So you will agree, I hope, that this is one student object and this is another student object, even though they have same name and same roll number, but these two are certainly different student objects located at different locations in heap, correct? Now when you use double equal to operator, double equal to operator will only check the value of this object reference st1 and object reference st2, which is going to be the plain memory address, right? And you can, I hope you agree that both of these will be pointing to different locations, right? And hence will have different addresses, correct? So the answer here will be false, because double equal to comparison always checks the memory address where the reference is pointing to. Is that clear to everyone? Anyone having any doubts? So people who answered true, is it clear now that why this will be false and not true? Okay, I hope that is clear. Again, I will, just for reference, I will again just repeat that part. So st1 here will basically point to some location, let's say 1000x, and this will point to 2000x in heap, right? So definitely they are pointing to two different locations in the heap, and that is why double equal to operator will give you false as the answer. Okay, because both are pointing to different locations. If, however, you say something like this, what is going to be the output now? Good. So I can see, I think people are clear about this now. So once you say st2 equal to st1, both are now pointing to same location, right? So answer is going to be true. Okay. Now let's say instead of using double equal to, what I do is I say st1 dot equals st2. What is going to be the answer now? Right. So this time I'm seeing a lot of trues and few false. So guys, let me remind you one thing, that this is all the code that you have. There, do not make any other assumptions at all. Okay, this is all the code that you have. Do not make any assumptions that this must be there, or this might, if this is there, or if this is not. Okay, everything is defined here. Do not make any assumptions about any other thing at all. Okay, so for example, I can see few comments regarding equals method. This is all the code that you have. There is no hidden code written anywhere else. Okay, so in this case, let me confirm that. So in this case, answer is going to be false. Okay, the reason is what you are doing this time is you can see you are calling the equals method, right? But clearly we do not have any equals method in the student class, do we? We don't, right? So that means which equal method we are using here? We are using the equals method from the object class. Okay, equals method is defined in the object class, and in case you do not override it in your class, right, you get that default implementation from the object class. Now, if you see the definition of equals method in the object class, this is the definition. Okay, and you can see it is a plain double equal to check. Alright, so unless you override the equals method of the student or of the object class, right, you get the default equals method from the object class, which has this double equal to comparison. Okay, so this is effectively doing the same thing that was being done earlier, the double equal to check. So unless you override the equals method, you are effectively doing the double equal to check, and hence you will get the answer as false here. This clear to everyone? Okay, now how can you get the answer as true here? It's very simple. All you need to do is you just need to override the equals method, right? So I will just quickly provide one very simple equals method implementation here. Okay, so in this equals method, ideally what you should do is first of all check whether the object that has been passed in is an instance of student or not, right? Because if it is not a student object, then there is no point in comparing that object with the current object, right? Okay, so definitely this should be there. After that, if it is a student object, what you can actually do is you can actually just do a quick typecast here. This is mainly for making your code less cluttered, because if you do not do this casting here, you will have to do it every time you try to access name or roll number from OBJ, right? So I do it at one place here, and after that I just have one return statement, return this dot roll number double equal to other student dot roll number, and this dot name dot equals other student dot name. Okay, string class in Java has equals method perfectly which is perfectly overridden, so you can actually use it freely, and you can see I'm doing that, right? I'm using the string class equals method here, which would work perfectly. And once you have this code, and if you run this, now you will get the answer as true. Now this will give you the answer as true. So Eugene, you mean to say what if the OBJ is passed as null, right? Right. So Eugene, if OBJ is passed as null, then this instance of student will return false, right? So you will directly return false here. Okay, it will not go inside this if condition at all. Null is not an instance of anything. So when you do an instance of check, in case OBJ is not pointing to anything or it is null, right, then this instance of check will return false. You will not go inside this, and you will directly return false, which is I think what you would expect, right? There are a few things further that you can do inside this equals method. You can see that I'm not checking for this name being null or not, right? Otherwise, because for example, if name is null for this current student object, you will get a null pointer exception here. So ideally, you can basically make this equals method as complex as you want, depending upon your requirement. Okay. So ideally, you should be doing a null check here as well for name, because otherwise, this is a source of null pointer exception. You should check whether name is null or not, and then only proceed ahead to do this equals comparison. But again, it's totally depends upon what kind of equals method you want. Okay. All right. So that was a very brief uh, thing before we actually go into the collections comparator versus comparable that I wanted to discuss. Any questions, by the way, anyone is having in this equals method? Is this clear to everyone? Okay, so I think then let's go to the thing that I wanted to discuss today. So I will start again with the sample code. So just give me 1 minute. So what I'm doing is I'm just creating a list of integers. Okay, I'll just add few integers to it. So you can see what I'm doing is I'm adding some integers to this list. I'm printing out the content of the list. And then I am calling this collections.sort method. Sort is a static method present inside the collections class which can accept any list that you want to actually sort, right? But what is the meaning of this sort? This is something which should be very clear to everyone. And now after that I will just print out the sorted list. I will just run this code once just to show you the output. Okay, so I hope you all can see the output here, right? The original list is unsorted, and after you call the collections.sort, you can see the sorted list. Okay, everything clear so far? This is very simple, right? Just an application of collections.sort. Nothing much complex here. Now, let's do one thing. Let's change this list from list of integers to list of something else. Okay, so what I will do is I will change this to a list of students. Okay, student class is the same that we created there. And I will just add few student objects here. Alright, so here the question is, once you have created this list of students and added 5 student objects here, as you can see, right, each with a different name and a different row number, I first of all print the original list, which will just give me these student objects here, right? And after that, I call this collections.sort. Okay, I have commented it intentionally. Assume that, let's say I uncomment this, and if I run this code, what is the sorted output that you are going to see? What will be the order of the student objects in the sorted list? All right, and people can actually type in the reason here as well, that why do they think that it will remain same? Because I can see some people are saying that it will be same. So for people who are saying it will be same, can people type in their reasons as well? Why do they think they will remain same? Right, so I can see a lot of answers now. So the thing is, guys, that this will actually give you a compilation error here. That's why I commented this out. The reason for compilation error is very simple, right? It's quite logical as well. If I ask you the same question, what will be the sorted list? I can see quite a few people asked the question, right? That what is going to be the sorted criteria, sorting criteria? Do you want to sort it on basis of name or on basis of roll number, right? Because you can do sorting either ways, right? So same is the question for collections.sort as well, right? How will collections.sort know that it has to sort this list of students on basis of name or on basis of, it cannot certainly do that, right? How will it have that business logic? Because this is a central code, right? Right? How to compare student objects should be defined somewhere else. All collections.sort should basically know is that once it knows that if this student object is bigger and this is smaller, just arrange them or swap them in whatever way it wants, right? Or apply basically any sorting algorithm like insertion sort, selection sort, or whatever. But it needs that information that which student object is bigger or smaller given two student objects, that must be supplied to it from somewhere, right? Clearly that information is not being supplied to it here. All we are supplying it is a list of students, and that's it to the collection.sort method, and that is why it is actually not working. Because it needs the criteria on how to compare two student objects. It doesn't know right now how to compare two student objects. Okay, so to make this work, what you need to do is you need to go to the student class and you need to make the student class implement an interface called, any guesses? It's actually comparable. Okay, what you need to do is you need to implement this interface called comparable. Okay, and here what you are actually going to do is in this compare to method, right? Naveen, I will come to comparator. Okay, comparator is having some additional benefits over comparable. So we will first discuss this, then we will find out what are the issues in this approach and why comparator is better. So you will have very clear understanding of why we should actually implement comparator and not comparable normally. Okay, now here once you implement comparable, the thing that you need to do is very simple. You just need to provide a good implementation of this compare to, right? What this compare to should actually return is, if the current student object is bigger than this parameter or other student object that you have passed in, you should return a positive value. If both are same, both student objects are same, you should return 0, right? And if this other object is bigger, then you should return a negative value. Okay, so for example, what I can actually do is, if I want to compare them on basis of roll number, I can have a very simple thing like this. If this dot roll number is greater than the other student's roll number, then make this student object as bigger, right? So I will say return 1. That is, current student object is bigger because its roll number is bigger. Else, if this dot roll number double equal to make them same because their roll numbers are same, right? And else, obviously the other one's roll number is bigger, so I will return -1 here. Okay, so I will just compact this one here a little bit. Now I go to the collections.sort example again, and now you can see it is compiling. Okay, Adil, I will come to that. That's very clever what you have written here. This dot roll number minus roll number. This is exactly what I was going to discuss next. So this is basically a very basic implementation, and obviously it can be optimized like the way that you have mentioned, right? But it could have confused people if I just wrote that initially, right? So that's why I took the very basic form, and we will discuss that. Don't worry. Now, if I run this code here again, let's see what is going to be the output. Okay, this is actually a beat, right? You can see this output is not meaningful at all, right? Whatever output is coming here, we are seeing collections demo.student and blah blah blah, the hash code or the address value, whatever you want to call it, but it's clearly not giving us the information about the student object, right? You can see the list is getting printed. This is a symbol of start of the list, and here is the end of the list, and you can see the 4 student objects inside it, but nothing meaningful is getting printed. Any guesses on what should we do now to make this output more meaningful so that we can see which student object is at which index? Yes, and has written absolutely correct. What we need to do is we need to override another method called toString method in the student class. Okay, once you do that, any object of student class, if it is passed to system.out.println, this toString implementation will be called. Okay, otherwise object class toString implementation is called, which basically just print out the class name followed by the hash code value, which is meaningless, as you can see, right? So what I will do here is I will just say return, okay, I will just make it simple, return name roll number, and I will actually add a /n as well so that we can actually see all the student objects. Okay, maybe we can actually ignore that. Let's forget about that. Need that. Alright, so we have overridden the toString method now, and now let's go and run this again. Okay, let me just do one more thing. Okay, this is just to actually separate all the student objects, okay, when we actually print this out. So let me run this again. Now you can see the output, right? This is the original list, and after calling collections.sort, you can see they have been sorted on basis of roll number. Okay, I can see a few questions regarding hash code. So guys, we don't need to actually override hash code in this question or for this example. Hash code is only needed when you want to store your objects in something called hash set or hash map, or basically any map implementation or any set implementation, because set or map actually uses the hash code method of your class to basically create groups, right, in which to actually organize objects. But anyways, that's again a long discussion, but yeah, for sorting purposes and for this particular example, you don't need to override the hash code, and you can see I haven't actually done that as well. Okay, so is this clear so far? Any questions anyone is having till now? Anything at all that is not clear? Okay. Now let me come to one of the thing I think which Adil mentioned a while back. So we can actually do a quick optimization in the compare to method here, right? And we can do that only because of the fact that the field that we are comparing roll number is an int field, right? Instead of writing this 3 if else condition, all what you can actually do is just reduce it to a single line. Okay, any guesses on what that single line could be? You don't need to have this if, then else if, and then else. Right, so Naveen, ternary operator we can use, but I'm thinking of something even more better than that. Okay, so what you can actually do is you can just say return this dot roll number minus param t dot roll number. This is in fact the implementation of compare to that you will find a lot in the exams question. Okay, because this is a little tricky on why they are doing this subtraction here. How is this going to work? Okay, this is going to work because you can see if the current object's roll number is bigger, you will return a positive value here. If both are same, you will return a 0, and if other roll number is bigger, you will return a negative value. So it is actually going to work, right? It will not return 1 and minus 1, but that is not required. L2 just needs you to return a positive, 0 or a negative value. So this is going to actually work. And Naveen, to your question regarding equals method, no, in this question now equals method is really not needed because this compare to method will be actually used, okay, for sorting. But if you do not do sort, then this equals method is very important, right? Because in that case, no one will be using this compare to in this method. Okay, now there is one problem with this approach. Right, there is one problem with this implement comparable approach. The problem is that you have to modify this student class. Right, what if you do not have access to let's say source code of student class? Okay, or let's say the student and the student class is let's say final as well, so you cannot extend it and make it implement comparable, right? Then in that case you cannot do this, you cannot make it implement comparable, right? So what is going to happen in that case? This you will not be able to do. So I will comment this portion out. Right, so if you do not have access to source code of student class, you cannot do that. Okay, and before I come to that problem, there is even one more problem here. Now let's say I ask you the question that, okay, this is good, whatever you have done, it's working perfectly fine. You are able to sort this list of students here based on roll number. Now I want them to be sorted on basis of name in next line, right? So after this line, so at this line, student should be printed on basis of roll number, right? And in the next line, after I call collections.sort or whatever you want, right? They should be printed on basis of name. Can I do that here? We cannot do that, right? Because our compare to method here in the student class is only comparing roll number. There is no way in which now you can sort these students on basis of name, right? So that is one limitation. That is another limitation. That is only one sorting logic you can define if you use the comparable interface approach. Okay. So I will now remove this from here, right? Because what we are going to do now is we are going to assume that we cannot make student class implement comparable. Okay. Its source code is not with us, right? And you can see that this collections.sort example is not compiling anymore, right? Again, for the same reason, because student is not implementing comparable, and whenever you call collections.sort and you pass it a list of something, that list should contain comparable items. Okay, now if you cannot make the list contain objects which are implementing comparable, what you can actually do is you can actually create something called comparator. That comparator can be created externally to the student class. In fact, most of the times it is created externally, right? You can create a separate class implementing that interface, right? And it doesn't have to be the student class, right? So for example, what we can do here is we can create something called class student roll number comparator. We can make it implement comparator interface. Now, when you implement comparator interface, you are required to add implementation of one method called compare. Okay. Now, again, this works in following way. If the first object is bigger, then you should return a positive value. If you think both are equal, then you should return 0. If you think this one is bigger, then you should return negative value. Right. So again, we will do the same thing. We will say return param t1 dot roll number. Oops. These are private, right? So let me actually make them default or give them default access level so that I can access them directly here. Ideally, you should create getters for doing that rather than accessing instance variable directly like this. But for this question, we can actually access them that. But again, this is not a good practice. Ideally, you should create getters here. Now, once you do that, you have your comparator. All you need to do is you need to call the overloaded collections.sort method. So there are actually two collections.sort method available. You can see one which is taking a simple list and another in which it is taking a list and the comparator object. So what we will do here is that we will say list lt and we will pass in our student roll number comparator as well. Okay, and now if I run this code, you can see the output, right, which is again the students are sorted on basis of roll number. Right, now that solves our first problem, that student that we don't need to modify the student class, right? We are doing this externally, we are not touching the student class at all, and we are able to sort a list of students. Now the other problem was that what if we want to sort students on basis of name, right? Now for that, all you need to do is just create a separate class, right? Without modifying the student class, just create a separate class called, let's say, student name comparator, and here say return. Now string class is actually implementing the comparable interface, right? So you can actually leverage that here. Okay, I can leverage that here and I can just call the compare to method of the string class, and I can just call collections.sort again by providing the new comparator and print out the list again. And if I run this code now, you can see now this is actually sorted on basis of name as well. So this is original unsorted, this is on basis of roll number, this is on basis of name, the last one, right? And if anyone is basically wondering that why the list of integer was getting sorted earlier without any of this comparable or comparator, right? The thing is that integer class actually implements the comparable interface. That is why it was getting sorted. I can show you that. So if I open the source code of the integer class, okay, you can see it is actually implementing the comparable interface. That is why you were able to sort the list of integers without any issues, right? Without creating comparator or comparable anywhere. But for your own custom classes, you obviously need to either implement comparable interface or you can actually implement comparator separately. Obviously, implementing comparator separately is much better because this keeps your code independent of the original class. For example, student, you don't need to touch it, and hence this is more maintainable. Plus, you can create as many sorting logics as you want and just plug it in the collections.sort method. Okay. Any questions anyone is having here? Anything that is not clear between comparator, comparable, which one to use when, why it is actually needed in the first place? All things clear? Vishnu, yes, final class can implement an interface. There is no issue in that. Shweta's question is why compare to is used for strings. Shweta, we are using compare to for strings because we want to compare string values name now, right? When we want to sort to a list of students, right? So instead of creating my own way of comparing two string values, I'm directly leveraging the compare to method which is present in the string class. So in the string class, there is already a compare to method present because string is implementing comparable, right? Which checks whether the current string is bigger than the other string. And we can directly use that, right? Why will you create your own logic of comparing two string values, right? When it is already provided in the string class. So that is why we use the compare to of string here. Right, so guys, I am actually done with my part. So if anybody is having any questions, please let me know. Naveen's question is what compare to does internally? Means does it use equals? Which compare to, Naveen, you are talking about? You are talking about the compare to of the string class or compare to of which class? Okay, now string class I'm not sure. Maybe we'll have to look into the compare to of the string class on what it is actually doing. But as a matter of fact, you don't need to worry about it, right? Why do you need to worry that whether the compare to of the string class is calling its equals method, right? Just know that the compare to method of string class should behave as you expect. That is, a bigger string value should be returned as a bigger string value, right? Irrespective of how it is implemented. Now, if you do that implementation on your own, like creating a string comparator, then you will need to take care of that whether you want to call equals or not. Peter's question is how to compare sort to sort descending. All you need to do is just change the logic here, Peter. So for example, you are saying on basis of roll number, I think it was ascending earlier. To make it descending, all you need to do is just return the opposite value, right? So when you were supposed to make the first one bigger, just make it smaller, right? So what I will do is I will just change this logic here. Right? So if the other student's roll number is bigger, then I will make it smaller, right? I will just reverse the logic here, right? When I was returning 1 earlier, I will return -1. When I was returning -1 earlier, I will return 1, right? And now if I actually run this code again, you can see now it is in the descending order, right? 5, 4, 3, 2, 1. Same will happen for the string if I reverse the logic there. Okay, now I can see a few questions regarding anonymous class and overriding hash code. So anonymous class, Adil, I will not be able to cover in this session because it's a broad topic, and frankly speaking, anonymous class should not be used that much because it makes the code more unreadable, I would say, and there is actually no benefit as such from the anonymous class than a normal class. Okay, only the fact that you can say the code is a little bit smaller and unreadable as well. And Huyun's question is, if we do not override hash code or compare to, what happens with equals? Nothing actually happens with equals because all these three are different methods. Hash code is one method, compare to is one method, equals is one method. They are independent of each other. You can provide three different, you need to implement them separately. One doesn't depend on the other. Although there is a sort of contract between hash code and equals. That is, if hash code behaves in a certain, there is basically a certain behavior. That is, if hash code returns this, then equals should behave in this manner, right? But again, that is a broad topic. You can easily search for that and just Google hash code equals contract, and you will actually see the guidelines for implementing hash code and the equals method. Okay. Okay, Raj, I think you can take over. Meanwhile, I will see if there are any questions in the questions panel here, and I will keep on answering.